basic 3 trig functions because you're going to need these when we get into the last part of our notes and we're actually calculating some sides and some angles. So, when you are looking at angles, sometimes the angle measure will have an X here, but many times it has this Greek letter there that is called theta that we use to represent the measure of this angle. So that's basically saying, hey, this is the angle that we're using here. So when we do that, you have your 3 sides at that point. The easiest one to always remember is your hypotenuse, because that's always the longest side. The side opposite of your right angle, no matter what other angles you're looking at. The other 2, though, are going to depend on where this angle is. So if it's here, if you start at this angle and you just start working your way across until you run into the opposite side, that's going to be our opposite. And the last one, which is directly connected to your angle, is your A. It's called your adjacent side. So the reason I say that is when we're trying to find these 3 trig functions, sine, cosine, and tangent, you have to know which sides you're using. So for sine, it's opposite and hypotenuse, or you can just think of it as O and H. Because you're always going to have at least 2 of these sides. You might have a third one sometimes. It depends. Nice. Cosine is adjacent over hypotenuse, or A over H. Absolutely. And tangent is opposite over adjacent. The only one that doesn't use the hypotenuse. Those are the only 3 that we are going to be dealing with. That's good. I'm glad this stuck. So now, we're going to use those 3 things. We're flipping already. We're going to use those 3 things to deal with sides and angles. So, when we get over here, find the value of x, round to the nearest 10. Here's what I would do. Find the angle that has a degree measure, not your right angle, but one of the other ones you'll have. And we're going to label the sides that we need. So the x and the 25 are the 2 sides I'm going to use. So I notice I have the hypotenuse, because I have the side across from the right angle, and I have the side that's opposite from the angle they gave me, the 64. So if I have to flip back and forth a little here, it's okay. But I'm just going to kind of jot these over to the side so we don't have to flip all the time. Because once I've got this, now when I label, I just got to look and say, okay, I got O and H, which one uses O and H? Well, this one does. So, the sine of 64 degrees, the angle does come into play here, equals opposite over hypotenuse. We're going to make a little equation out of this. But let's even make it a little easier. Instead of necessarily, do I want to try it this way? No, I'm going to do it this way. So I look, if I want to solve for x, and I'm dividing it by 25, what do I need to do to undo that? So since we're dividing by 25, we're going to multiply both sides by 25 to make that go away. So x equals 25 times the sine of 64. Okay, The calculator is going to do this for us, but we got to check one thing every time. And we're going to put a big star here. Your calculator needs to be in degrees. Well, where the heck do I know if it's in degrees? So when I go here, so when we're in the calculator, if you go to mode, there's all this stuff going on here, but the one thing we're paying attention to is this one right here. We want it to be in degree. If it's in radian, all of our answers are going to be messed up. So, since we're in degree, we're happy. Okay, we can get out of there. We're just going to type this in exactly as we see it. So 25, here's my sine, cosine, and tangent. So sine of 64. And we're rounding to the nearest tenth. So 22.5. And we're done. That's it. Your whole job when you're doing these is to find your angle, figure out what side you got. So let's see. Opposite. We do not have the hypotenuse this time because there's my right angle and we're going across. So that did not happen. But I do have my adjacent this time. Once I have those two sides labeled, there's O and A. The tangent of 47 degrees is opposite over adjacent. And we're in a very similar situation as we were on the first one. So we're just going to multiply both sides by 12. We're going to make that go away. X is 12 times the tangent of 47. Which looks like it's about 12.9. We're off and rolling. Now, Hardy, does it get to be this easy all the time? Is there going to be some silly twist that you're about to talk about? There's a silly twist I'm about to talk about. So, let's go to where the silly twist is. We're going to go to these two. So, I'm doing my thing, and I'm like, all right, I got the hypotenuse. It's across from the right angle. I got the opposite. It's across from the 63 degrees. So I'm like, okay, we're back to sine, so that's not really weird. Yeah, if you start at the corner where your angle is, and you just kind of take your pen and you start going across until you run into a side, that's the opposite every time.
Okay, so the one that like it's on would be the adjacent?
Yeah, adjacent is literally connected to your angle. Yep. Yeah, that'd be, so if I had it, there would be, there's my adjacent side. So here, I look and I'm like, all right, so opposite over hypotenuse. Ooh. Ooh. So now, the number's not in the denominator. Now x is. So that's going to change things a little bit. Because I still got to solve for x. You're like, well, what the heck? It's in the denominator. Okay. Let's multiply by x. This is going to seem weird, but give me a chance here. So that cancels. And I've got x times the sine of 63 equals 27. But this time x isn't alone in one step. I'm going to have to do one more. So since I'm multiplying x by the sine of 63, how do I undo it? So that's the big twist. We're just going to be dividing instead of multiplying. Now, if you really get to feeling comfortable, to be honest, here's the trick. If you're dividing by a number, you multiply it times the trig function. If you divide by x, you're dividing by the trig function. Like, you can do it instantaneously if you want to. Otherwise, algebra is always a good idea. Okay, so here's my angle. Let's see what we got here. We got the hypotenuse. We do not have opposite this time. There's nothing over here. But we are connected there, so we have adjacent. So let's see here. Jason, I've got some cosine working. So cosine of 30 is adjacent over hypotenuse. So again, you could jump right to 18 divided by cosine of 30 if you notice the pattern. But if you don't, that's okay. We got algebra to depend on, so we're good. So we got the x out of the denominator, which we needed to do. So let me do that one last step, and then I'll show you how that works. It's a little bit of a shortcut, is what it is. So here, we're going to do 18 divided by the cosine of 30. So we got like 20.8 here. But when I talk about a shortcut, let me bring this back down a sec. So here's the deal. When you set up your initial little equation, if you are dividing by the number, when you go to get the answer, you're just multiplying these two values together in reality is what's happening. If I get the algebra completely out of it. If x is on the bottom and you're dividing by it, you're going to end up doing the 27 divided by this, or the 18 divided by this. I know that before I even start.
So
that's just a pattern.
Opposed to like canceling them out, you can see sin 64 equals x or whatever. You can just do sin 64 times 25.
I got 20.7.
20.7 what though? If that number after 7 might happen to be 8, we need to be going up. Oh dear. So, that's how we find sides. There's one last difference when we go looking for an angle. So here's what we're going to do. Just to kind of give you a little heads up to remember here. So if I'm looking for an angle measure, I'm actually looking for the inverse of sine. Now, it doesn't mean we're just going to flip the fraction. That's not what I mean. Nope, that's theta. It's just our angle measure. It's a fancy name for angle measure. And so, for all of these, their inverse is how you find the angle measure. But we're going to show you how to do it on the calculator. It's going to make life a little bit easier on us. So, we're going to still do what we did in the last section. We're going to find, you're like, wait, they don't have an angle measure for us, though. It's just that weird-looking 0 theta thing. That's the angle. So I look, and I'm like, okay, there's my opposite. We do not have the hypotenuse to use this time. There's nothing over here. There's my adjacent. So I know that it's tangent, because that's the one that uses O and A. Opposite over adjacent. So here's how we're going to do this in the calculator. To get that little -1, yeah, we're going to do second tangent 8 over 14. So we're going to come here. Second tangent, there's the little -1. That's how we get it. And then we just type in the fraction that we have. And that is going to, again, now I'm doing angle measures, though. So we've got to put degrees with it. There's no fancy flipping with these. like there was up there, it's going to work the same way every time. So I look, I'm like, all right, there's my right angle, there's my hypotenuse. Here is the angle I'm using. Nope, no opposite this time. So this must be adjacent. So adjacent over hypotenuse is cosine. Adjacent over hypotenuse. Second cosine. Whenever you're doing angles, you got to see the little -1. Otherwise, it's not going to work. And that's how you find angle measures. As long as I see degrees is more important to me than that is. So as long as I see degrees on an angle. As long as I see degrees, I'm good. So, yeah. So, no, I'm not giving it to you right now. So, let me do this because I've been doing this all along. So, your last practice, well, besides final review, your last practice is over on page 3, 1 through 9 only, then you stop. Some you're finding sides, some you're finding angles. Yes, this will be on the option quiz tomorrow. So be ready. Those 3 practices that we're doing, the little parts of them, all 3 of those things will be sitting there waiting for you